Greeting to Doctor and my fellow friends. We are from BEJ44103 Intelligent Control System, Section 1, Group 4. First of all, I would like to introduce myself. My name is Tichian and my metric number is CE2073. And I would like to introduce my group member, which is Chong Lee. So in this video, we would like to explain and demonstrate how to construct the assignment 2. So first of all, we look into the introduction. Fuzzy logic is the method of performing conditional logic tests based on input that are not crypt. Fuzzy logic based on the Fuzzy set theory, which is a type of set theory developed deal with set with the property that object can be partially obtained in a set. Fuzzy logic is applicable to AI programming, since this is the way to describe the type of conditional that we would really like to ask in conditional logic change. So next we look into the component of fuzzy logic. So the first component is fuzzification, the process of transforming the numeric input into a form that can be used by the inference mechanism. This relies on fuzzy set and membership. Second is the rule base, a set of if-then rules about how to control the fuzzy logic. So the next one is the inferencing engine. Information about the current input formed by fuzzification, decide which rule apply in the current situation, and form conclusion about what the plan should be. The last one is the defuzzification, converts the conclusion reached by the inference mechanism into a numeric input for the plans. So next, I will demonstrate how to construct the task 1 by the membership function with 3x3 rule base. So first of all, we need to open into the MATLAB software and type some coding at the command window. First, we need to clear all the operation in the command window. And next, we need to input our fuzzy PDI into our MATLAB. So we just drag into it, and the MATLAB will automatically create the coding for us, and it will show the fuzzy PDI in the Simulink. So next, we need to enter the command of fuzzy to open the fuzzy logic designer. So next, we need to import the data of our FIS file into our MATLAB. So as you can see here, our group already create the FIS file of our fuzzy logic, which is the first input is temperature, the second input is the cloud cover. So the output of fuzzy logic will be the wind speed. So the FIS file of this fuzzy logic we need to import into our MATLAB. So after we import the data into our MATLAB, it will show the fuzzy post underscore 3x3. This is our FIS file. So next we need to edit the rules of the fuzzy logic. So this is the 3x3 base rule. So we have the 9 rule of this fuzzy logic. So this is the 3x3 rule base of fuzzy logic. So next we need to export to our workspace. So after we click export to our workspace, it will show the file name in the workspace. So next we need to import the fuzzy logic designer into our fuzzy PDI. So next we need to open back the fuzzy PDI in the Simulink, and we double click the fuzzy logic controller. Next we need to set the FIS name. The name must be same as the file name in the workspace. So we set it correctly. So we just click OK, and then we click the run button for running the simulation of fuzzy PDI controller. So after the fuzzy logic controller is completely run, it will show ready 100%, and it will show the result in the workspace. So next we close this window, and we can write the command of this plot in our command window to plot our figure of the graph. So as we can see here, we have successfully run the simulation, and the graph is shown at the figure 1. So that's all for the task 1. Thank you.
A very good day to Doctor. My name is Chong Ling. For this assignment 2, I'm going to talk about the task 2, which is the design a fuzzy membership function with 5x5 rule base. So this is the block diagram that is provided by lecturer. So this is the fuzzy PID block diagram. So first thing first, before we run this block diagram, we have to declare the fuzzy in command window first. After we declare the fuzzy, then it will appear the fuzzy logic designer like this. Then so here is this is our group on design for the fuzzy post. So we have temperature, cloud cover, and then the wind speed. So for the more detailed explanation, my group member already explained before this, so I will just skip. So after we have designed our own fuzzy post, so for 5x5 rule base, we need to do 25 rule base based on the on the fuzzy force. Now we can export this design to our MATLAB workspace. After we click export to workspace, then this will appear in the workspace. So the fuzzy force new is already appear at the workspace. So next, after this, we need to go back to our Simulink, and then we double click this fuzzy logic controller, and then we need to rename the FIS name as our own save file name. So for my group is fuzzy force underscore new. And then we click apply. Then we need to click run. After we click run, we have to wait about like 1 to 2 minutes for this to run. After this have completely run, when this is shows ready, we need to go to the MATLAB common windows here. You can see that the T, X, and X5 already appear in the workspace. So after this X appear, we need to declare the coding, which is to plot the graph. After we have plot, the graph will shows here. So as we can see that this is the graph that we obtained from the simulation. So as you can see, the red color here is for the fuzzy logic. The blue color line is for the PID controller. So I have point or depict the graphic here. We obtain the result for fuzzy logic is 4.664, and then the Y is 73.9697. For PID, the X value is 6.595, Y is 69.9171. So this is not much different for the value, but we can see the fuzzy logic has a better performance compared to PID. With this simple design approach can give better performance than PID controller, like as I mentioned before. So the fuzzy logic controller provide a better performance instead of percentage overshoot here. So this fuzzy logic controller also give more attention to various parameters such as the time of the response, the steady state, and overshoot. So that's all for the task 2 demonstration. Now I will discuss about the comparison for 3x3 and 5x5 best. So based on these two results, we can see that the result for 3x3 we get 6.474. For the result for 5x5 we get the we get 4.487. So which means that the 5x5 rule best offer the better result compared to 3x3. So because the number of the rule is increased on the 5x5 rule best, so it can achieve and it can perform the better performance and achieve the accuracy. Based on this result that we get, we can see that the result for 5x5 have the can be the fastest to reach the steady state condition. So as a conclusion, the fuzzy logic controller gives better performance than PID controller. Then fuzzy logic is used to enhance them due to its ability to translate the operator's control action into a rule base, which allow the consideration of inaccuracy and uncertainties. Both of the controller are able to control the program and remove them considerably. So that's all for my presentation. Thank you.